This is a boiled egg. When we leave it on the table, it prefers to stay in lying down position. Even if we make a stand up, and when we leave, it goes back to lying down position. But interesting thing happens when we rotate this boiled egg. Now it seems it prefers to stand up and dance. It keeps on dancing, and at the end it is exhausted and once again prefers to go in lying down position.
वो ऐसे कैसे हो जाता है फिजिक्स?
Let us see whether we can understand this behavior with energy considerations. Before we start, we need to know the moment of inertia for this boiled egg. So for that, let us say that we can approximate this to be an ellipsoid with major axis radius to be c and minor axis radius to be rho. Then we know that when it is rotating about a minor axis, then its moment of inertia is going to be 1 by 5 m rho square plus c square. On the other hand, when it is rotating about the major axis, then its moment of inertia is going to be 1 by 5 m rho square plus rho square. Although we should be careful because egg is really not an ellipsoid. It has a wider diameter at the lower half. But let us see with even this condition whether we can have some understanding. So first let us talk about the potential energy, and what we can see is that when the egg is in horizontal position, then its center of mass is at lower height above the table surface. So in that condition we know that its potential energy is going to be lower, let us say mg rho, and when it is in vertical case, then we will be having potential energy mgc. That's how we can say that when it is not rotating, and then it will prefer in horizontal orientation, so that we have minimal potential energy. On the other hand, when we rotate, things change. Apart from potential energy, we have to also consider the rotational kinetic energy. And then what we can see is that in horizontal case, we will be having the potential energy as mg rho, and kinetic energy will be half I omega square. And in this case, I is going to be 1 by 5 m rho square plus c square. So that's how we will be having this expression. Similarly, in vertical case, we will be having a total energy expression as mgc, that is potential energy, plus half I omega square, which is going to be half into 1 by 5 m rho square plus rho square omega square. Now it presents one interesting case. We can see that potential energy minimum will be happening for horizontal orientation. On the other hand, for any omega, we will be having lower rotational kinetic energy for vertical case. So that means it will depend upon omega, and for omega larger values, there might be a scenario that we will be having total energy lower in vertical case. And that's how it looks like that when it is rotating and becoming vertical, it is purely energy minimizing considerations. On the other hand, we have to be careful because we also note that when it is rotating and we have seen that lower half has a wider diameter, that means the center of mass is going to be slightly lower, but when it rotates, the wider portion goes up. That probably we will not be able to explain in terms of energy considerations. And also we need to identify which are the forces, torque, which takes it from horizontal position to the vertical position. This we will discuss in some other day. There is interesting physics when we use raw egg instead of boiled egg. In this case, now it is going to be like a liquid body rotation instead of rigid body rotation. So it's going to be difficult to rotate it with a high omega, but once we start rotating it and we stop it momentarily and leave, it still keeps on rotating. Now this is not hard to explain this. This is going to happen just because of inertia.